Assalamualaikum, my name is Nur AMIRA binti AZIZ alias IDRIS.
My name is Muhammad SYUKUR bin IDRIS.
My name is DANIAL bin MUNIR.
In these presentations, we will discuss about Latched encoder and decoder systems. Now, let's get started. We can use an IC magnitude comparator to perform binary comparisons. We can describe the function of a decoder and an decoder. We can design the internal circuitry for encoding and decoding, and also we can use manufacturer's data sheets to determine operation of IC decoder and encoder chips. This is an encoder. Encoder is a device or a transducer or a circuit. The encoder will convert the information from one format to another format, like electrical signals to counter or a PLC. And the feedback signals of decoder will determine the positions, count, speed, and directions. The control devices are used to send the command to a particular functions. This is an decoder. Decoder is a circuit used to change the code into a set of signals. The name itself tells the decoder because it has the reverse of encoding. The decoders are very simple to design. There are two different types of encoders, which is linear and rotary. A linear encoder responds to motion along a path, while a rotary encoder responds to rotational motions. As you can see, this is a linear encoder. This is a rotary encoder. The applications of the encoder is you can ensure that the unit to be controlled does not exceed a preset positions or direction of travel. You can attach to the end of the ball screw, shaft, or driver motor. Encoders provide motion feedback. You can provide high frequency motion feedback while operating in extreme environmental conditions, and you can provide feedback for speed, directions, and precisely control operations. Decoder is the conventional circuit that changes the binary information into two and output lines is known as decoders. Binary information is passed in the form of an input lines, and the outputs define the 2 and bit code for the binary information. In simple words, the decoder performs the reverse operation of the encoder. There are three types of decoder, which is parallel decoder, balanced decoder, and tree decoder. Parallel decoder network has the advantage of being fastest and most regular in constructions of the three types. In tree network decoders, there is 4 flip-flop and so has 24/16 output lines, and examination will show that 56 diodes are required to build it. There is another type of decoder which is called a balanced decoder network. This network requires only 48 diodes, and it shows that the types of decoder network requires the minimum number of diodes. The applications of the decoder is microprocessor memory systems, input and output systems, instructions decoding, and memory chips.
I will presenting about component we use in this circuit. In this circuit, we use logic state as keypad to input the number from 0 to 9. Then we use 7410 triple NAND gate. Then we use 7420 for input NAND gate. In this circuit also have 7432 OR gate. We'll also use 74121 one-shot multi-vibrator IC, 250 picofarad capacitor, 10,000 ohm resistor. Then we also use 74147 encoder IC, which is have 10 input to 4 output. Then we'll use 7475 4-bit transparent latch IC. Then we use 7447 is a BCD to 7 segment decoder. We also use 150 resistor, and lastly we use 7 segment LED display to display the output.
And I will present for output simulation. When one of the logic step is pressed, the current will flow to two parts, which is encoder and AND gate. From the encoder, current will flow to 4-bit bistable latches, and from AND gate, it will pass through OR gate and then to monostable multivibrator and will continue on monostable multivibrator. Next, current will connect to BCD to 7-segment decoder and finally will connect to 7 segment as output.
Output from the given circuit as required. Output is from number 0 to 9. We have a problem on that circuit, which is the keypad. To sketch the circuit, we use Proteus software and Proteus does not provide it. As a solution, we replace it with logic states.